Yeah. So students, a very good afternoon to today's class. Okay. So now we'll be starting our class. A very good afternoon for today's class. So this is our first class, students. That's fine. So we'll be starting a chapter that is unit and dimension. So what the chapter we are starting is, it's unit and dimension. So let me check on the YouTube what the students are doing there. Okay, it's working there. That's fine. So how are you all the students? We'll start it soon now as it is. You can see live on the YouTube. And for all the Zoom students, yeah, that's fine. Yeah, it's free of cost, Okay, don't worry about that. You just be focused here. Today we'll be starting from a very basic thing in physics. Okay, we'll understand the physical world around us. We'll understand some beautiful terms in physics today. Okay, we'll talk about all these things. That's fine. So we are going to talk about. So here we go. So here it is, live stream on both the platforms. You can see. Okay, let me check on the YouTube somewhat. Just wait for a second, students, okay? We will start perfectly at 4:30, maybe sooner than that. By the way, how are you? You can put the comments in the comment box also. Okay, here Zoom, on the Zoom if you want. Okay, it's better to put on the YouTube. That will be more better, okay? It's better to put on the YouTube. That will be more better. So I hope the sound is fine. Let us start it, students. Okay. So as it is working, let us start it. Yeah. So today, what we are going to do is this. We'll understand this chapter. This is, students, from a very basic physics. Remember it. This is from where? This is from a very basic physics. Okay. So these are the contents of today's topic, students. These are what? Contents of today's topic. Okay. First of all, we'll go through the scientific method. This is what a scientific method. Then we'll understand, what is actually physics is. We'll understand this. Okay. We'll also understand impact and the uses of physics in the environment around us. Okay. After that, we'll be going through the knowledge. We'll be able to understand that what is the scope of physics in today's world. Okay. After that, we'll get to know about somewhat about the fundamental forces, and then at last, unification of these forces. Okay. So without wasting time, here we go. So what is science actually? The first and the basic foremost, like first question is, what is science according to you? Anyone? Yes, science. Okay, we think what is science? Science can be something which about we can understand the natural phenomena around us. Okay, so if you see here, these all phenomena. Okay, if you understand why this, like, sky's color is like this violet and bluish kind of. Why when when there is a rainy season, and why there is a current or electricity. Current. This is what, something like electric shocks, like electric waves in the sky, why it gets generated. And you know it now, it's due to charges. We have studied in lower classes. Okay. We'll also understand that these all, what are these? Anyone? These are what? Yes. These are the planets in their orbits, revolving in their orbits. Till now, we only guess through the word science that science is all about these old studies, sky, electricity, the natural phenomena around us, and far away from us, even the closest to us. Understanding the earth is also in the science. The birds flying, everything is science, isn't it? So, but if we want to explain somebody via some theoretical definition, so what we'll say? We'll say like this. Via theoretical definition, students will say like this. Hold on. That Science, what is science? Science is a systematic attempt to understand natural phenomenon in as much detail and depth as possible. Okay. So what are the natural phenomenon is there? If you want to understand in that phenomenon up to as much as depth you can understand, this all comes under what? Science. Okay. We also say like this, knowledge gained to predict something, modify and control that phenomenon. See, how can we say to control? I mean, some of the natural processes we can't control, but we can predict it, like weather prediction, whether it will be cyclone, some dangerous. See, these natural kind of disasters can be very, like it can be very misfortune for the humans, be human civilization. So by the help of this science, we can predict it, before, and we can make some arrangement. Although we can't control it up to a lot of extent, but still we can predict it. And some controlling phenomena you can take, like, it that if you know it already that the outside the weather is not good, so you must not go for long drive. Okay. Science has also been cited like exploring, experimenting, and predicting from what we see around us. That's a very easy thing, isn't it? So if I include all this definition in a single word, I can say like this, that systematic observations, okay, controlled experiments, qualitative and quantitative reasoning, mathematical modeling, prediction and verification, all of these theories are under the science. Okay. So if we go through this, some of the words, unification, okay, I mean, this explains us a diverse physical phenomenon in terms of few concepts and laws. So all these are basic things to us. Okay. So if you want to understand the unification law, if you want to understand this unification thing, this is what the unification. Okay. The best example is laws of gravitation. You know the story, and our channel is what? Newton EduTech. You know the story that, the Newton was Sir Isaac Newton was, sitting below the tree, and an apple fall down, and from there actually it started the journey of what? Finding the laws of gravitation. We all know this thing, isn't it? Yeah. And some also other examples you will understand in the higher studies. I mean, in this channel only you'll understand this thing, that there are many basic laws of electromagnetism. Okay, Maxwell laws, which govern all the electric and magnetic phenomena. So these are all things also you'll understand. Many of the things are included in unification, not only about the magnetic laws and the laws of gravitation, even the rolling of, this earth is revolving, it's rotating and revolving around the sun, rotating on its axis. All this science are under some laws. Okay, that also you'll understand. These moving of a satellite, these all things you'll understand in the chapter gravitation, not now. These all things, students, you will understand in the chapter gravitation. Okay, good. So if you see this thing, students, I launched this a very interactive and very interesting video for you. Try to understand what is happening in this. Okay, try to understand. First, you will observe what is happening. Then I will explain you. Then we'll share our views. Okay, so here we go. You can see here, students, as I am, what I am doing here, as I am increasing the level or pushing this button, so something this thing towards up, heat is being generated. Heat is what? Heat is increasing. As the heat is increasing, initially the molecules which were still now are randomly moving. Why? Because they have gained energy. And energy can't be created, can't destroy it. It gets transformed from one form to another. So these molecules have gained the energy. You can say the heat energy has been transformed into what? Kinetic energy. Now, as I decrease the level of this button, I push it down in the cooler manner, ice is coming outside of it. So what is it? It's actually doing? It's decreasing this heat energy. It is what? It is compensating the heat energy. It is decreasing the kinetic energy, which was initially the heat one. Okay. So you can see now after a few minutes, what's going to happen, or after a few seconds, as per this video, all the molecules are back again in their static position. Isn't it? Wasn't it a cool observation, students? Let us launch it again and understand. Try to understand again. Okay. Let us launch it again and try to understand it. So here we go. Initially the molecules are static, but as I increase the heat energy from the base, you can feel the temperature. This is your finger. Suppose this is your finger. You can feel the temperature, isn't it? Let me highlight it. This is your finger, suppose. You can feel the temperature. It is 19 Kelvin, 20 Kelvin, 21 Kelvin. And via this thermometer also, you can see the level in this tube, which is increasing. So as I've increased the heat, you can see the heat is so much. So all the heat energy will pass through this because this is conductive. Okay, this material of this kind of glassy material or this jar is conductive. So heat passes. And now if I increase, I mean, if I decrease the temperature or if I increase this coolness in this jar, I mean, if I decrease this, you can see a very cool animation. Ice is coming out. So what does it mean? It means actually the temperature is now decreasing. You can see now 19 Kelvin, 16, 14, 10, 9, 8, 7, 6, 5, 4, 3, 2, and back again. All the molecules are what? At the static position again. So through this, it's a very cool observation. We can understand what is actually happening. Isn't it? What happened? As the temperature increases, the molecules move randomly here and there. But as the temperature decreases, molecules are back again in the static condition. Okay. So from this observation also, we can extract many of the physical laws. Got it? Yeah. So let us see one more observation. Okay, I think this is the same. As the heat is increased, molecules will be moving randomly here and there. Fine? Yeah. As it is cooled again, now what's going to happen? As it is cooled again, the molecules will be again in static condition. So there is some term which is known as reductionism. What does it mean? It says to derive the properties of big complex system, interaction of its constituent simple parts. This all thing comes under what this, I mean, this actually means reductionism. Okay. Examples are temperature, pressure, and elasticity. Okay, let us see. We have seen actually this previous animation, what we were able to see, that we increase the heat, what was happening, and decrease the heat, what was happening. So to extract some information from this complex system, okay, we have to do some reductions also and additions also. I mean, we have to do some reductions or we have to increase the levels also of that button, this one, okay, through which the heat was increasing and decreasing. Gravitational force. If we talk about, see, in this beginning, we'll not talk about a lot about this force, okay, somewhat. Let's suppose we're having a mass m1 and this is mass m2. If the force says, see, always remember Newton founded this thing. The forces between the masses will be what? Attractive forces, okay? So this F1 and F2 are the attractive forces, and then magnitude will be same, equals to G, which is a universal gravitation constant. It is having some value 9.11, I mean 6.67, 10 minus 27 like this. And masses are m1, m2 upon r square. So from here you can predict the forces are inversely proportional to r square or directly proportional to 1 upon r square. Also, it is proportional to the product of the masses. Okay. And remember, gravitational forces are always attractive forces. Okay. And this is a universal force, always I mean, it's applicable everywhere in the universe. It's a weak force. This also you must remember. So this is the point which I must mark with star point. Okay. That this is actually a weak force. And you know, it governs the motion of Earth, planets, and gravity. This we all know. I mean, you'll understand this thing in a more better way in the gravitation chapter. That's fine. Okay. So electromagnetic forces now. Students, we are now discussing the nature of the forces somewhat, okay? An overview. So see this thing. What's happening? These are all magnets actually. So see a very beautiful experiment you're able to observe here. These are all magnets. And you can see the north and the south pole, north and the south pole, north and the south pole. Automatically, you know, it's like a game. Suppose if I move one of these coins, which are actually magnets, north and south pole on both of the faces, so they will align themselves automatically as per which pattern? The pattern will be this: north, south, north, south. because we know north and south are unlike poles, and we know this thing. It's a natural experiment that unlike poles will attract each other. What going to happen? Unlike poles will attract each other. Unlike poles will attract each other. Unlike poles will attract each other. Okay. Unlike poles will do what? Will attract each other. Okay. So observe it carefully. Now let us talk more about this electromagnetic force. Okay. Suppose we're having a positive charge and a positive charge. We know this thing, it's from a very basic, I mean, we have seen this in the lower classes also, you know, that two positive charges, these will be what? Like repel each other. This positive charge will repel because these are the like charges. This is the law of the universe. Experimentally, it's been seen and found. Also, the mathematical equations have been like in the past been derived that like charges repel each other. Negative and negative are also like charges, they will repel each other. But positive and negative are basically unlike charges. So they will actually do what? They will attract each other. Okay. The nature of the electromagnetic forces are of these kind, attractive and repulsive force. So attractive acts on pair of charges or poles. It's a strong force. Electric and magnetic forces are not separable. What is it? What's it written, students? It says electric and magnetic forces are not separable. You know, you must know this thing. Okay, let me explain you this. See, you will understand there is something known as electromagnetic wave. We'll talk about it, but I'm just giving you an overview. I'm just giving you an I'm giving you what? An overview. Okay, this is something like an electromagnetic wave which passes with the speed of light, and it is having electric fields and magnetic fields perpendicular to each other. It is having what? The electric fields and magnetic fields perpendicular to each other. Okay. Yes. And let us see, this is as per the nature of forces topic. That's why we are talking about, just for the theoretical purpose. Now, strong nuclear forces are what? Remember, gravitation force was what? Gravitation force was weak force. Okay. Strong nuclear forces. These are the strong forces. Students. Strong. So in the nucleus, the forces are strong. Remember it. Okay. The force which binds the proton and neutrons, which see combinedly they are named as you have studied in chemistry. Yes, anyone. This is neutron, not neutron. This will be what? This is nucleon. Okay. This is named as nucleons. Attractive in nature, 100 times stronger than electromagnetic forces, charge independent. Of course, we know this thing. Neutrons are not having the charges. Even the protons are there, but still the force between the proton and the neutron is charge independent. It doesn't depend upon the charge. Remember it. Okay. But the range is small because you know there is a nucleus. Nucleus ke around there is orbits. In the nucleus there is what? Neutron and proton, which is nucleons, and the force binding them is nuclear force. You know the range. I mean, you know this thing. Actually, the radius of the nucleus is very, very, very small. So think how much small will be the range of the force. Okay, fine. If we talk about so there are kind of nuclear forces. There is also something known as weak nuclear force. Okay, this is seen basically in the nuclear processes which you will study in this high school 11th physics at the end of the chapters. Okay, I mean when we'll start the nuclear modern physics. Okay, basically in the beta decay, this thing is observed that there is a weak nuclear force in that. Remember, this stronger than the gravitational force, but weaker than the stronger nuclear force. Okay, so if we talk about, I'm writing in the short forms, just the symbols, V and F, which means weak nuclear force. These are basically what? Stronger than the gravitational force. So gravitational force is, you can say, if you compare this gravitational force, it is weaker than the nuclear force always. So weak nuclear force is greater than the gravitational force, which is basically F equals to G m1 m2 upon r square, but it is always less than the stronger nuclear force, SNF. Okay, remember it is charge independent, Range is very small again, that is 10 is to power minus 16 meter. Okay. So there is a ratio of this forces given: gravitational force, weak nuclear force, electrostatic force. Okay. And the force may be in between. Okay. These are the strongest force. Okay. That's where it's coming 10 is to power 38. So which is greater? 10 is to power 38 will be greater. No, of course. Will, as compared to what? 10 is to power 36, 10 is to power 25. Okay. And 1 is to power 0. Strongest force, electrostatic force, weak nuclear force, gravitational force. So remember, the order is this: gravitational force is the weakest force. This is the weak nuclear force, electrostatic force, and the strongest force. Now, students, there are some pictures for you people to understand in a more better way. Strong force basically binds the nucleus like this. Weak force is in the radio decay. Electromagnetic force, you can see from the picture what is happening. Electrons and protons are being binded. Gravitational force binds all the universe. I mean, all the particles in the universe, even the heavenly bodies. So gravitational force governs the universal laws of gravitation. I mean, it governs what is happening in the heavenly bodies, sun and the planet. There also this force will be acting, that is G m1 m2 upon r square. Okay. Now let us head towards the future topics. I mean, we have we understood actually whatever the things. I mean, in physics, what is the physical world? What are the different forces which we'll be studying in the upcoming physics sessions? Okay. Here we are talking about the branches in physics. I mean, there are many branches. The first and the foremost important, which through which I mean via which we'll start, is this branch, that is mechanics. So at first we'll be starting with the mechanics, motion and its causes. Okay. Next we'll be starting with after mechanics we'll go through vibration and waves. After that we'll go through thermodynamics. After that we'll go through maybe optics, electro, nuclear, and atomic. We'll do back to back. Okay. So this will include in this single chapter, but the rest of the things will go like this: 1, 2, not this, 3, 4, 5, 6, 7 will be combined in 8 chapter. So these are the sub chapters. Okay. So this is how we'll progress. Now comes the use and the impact of physics. First of all, before starting it, I want to ask from you, what do you think? What are the uses and the impact of physics? I want to ask from you, what are the uses and impact of physics? Any one of you? See, this picture is the picture of what? Your laptop. Your laptop. Okay. This is one of the result of physics. I mean, we understood electronics. We understood the theory. We understood the experiments. We controlled. We gained what? Hold on these things, electronics, experiments, everything. So which we were able to put or implement. See, it is not just the work of one person. It is the work of many people who are working from the past history to today's modern physics. So they worked on it, and ultimately they created a new branch via using the fine physics, that is the electronics, the branches of physics, and they implemented a technology like this. Okay, so this is all what? Results of physics or science only, you can say. So this is what? Whatever, fridge, refrigerator, this comes from where? The engineering physics. Okay. This is also what? The satellite engineering physics. This is what? A single formula equals to mc square provided this. Okay. I mean, many things can be, founded from this. Many things can be made, discovered by this uh, formula. I mean, this is just a formula which contains in it a lot of information. Okay. So this is a result of what? This equation equals to mc square. So questions to think and discuss, not only in India, students. If you see the people who are watching this from outside, if you understand, if we focus on the science, and more peculiarly, if I say, if we focus on the physics maybe, if we focus on this, students, we can use the physics laws for the positive in a positive manner, or we can say we can use it in what? Like an optimistic way, rather than using it in what? In a negative sense. Negative sense will bring us what? Well, negative sense will bring to the humanity or the mankind destruction. Positive will bring what? Happiness, which everyone wants, isn't it? Okay, let me color this. We want what? Happiness. So always think in a positive way and use the laws of physics. Okay, fine. So students, now if we go from the conclusion from the beginning slide, you can see this thing. We started with what is science. Then we have seen a simple theoretical definitions of science. Also, we have discussed our own views on science. Then we have seen some fundamental concepts of physics. We have seen unification. We have seen this experiment in which we got to know about reductionism. What is that? That increase the temperature. That thing you will include in this. Then we have talked about the nature of forces. We have seen some forces, gravitational force, which is basically a weak force, electromagnetic force, which is stronger than gravitation, but not a lot strong than the nuclear forces, strong nuclear forces. Then we have seen among the strong nuclear forces, some forces which are weak nuclear forces. Then we have arranged an order here. You can see here, this is the order. This is the order, students. Gravitational, weak nuclear forces, electrostatic, and the strong nuclear forces. Strong is the strongest. Electrostatics after that. After that, the weak nuclear forces, but the gravitation is the weakest force. Okay. Then these pictures were explaining you some the things which we have studied in the previous slides in a more better way. And then we talked about that. What is our future plan? Okay. And the uses and impacts we have seen. Everyone knows this thing. Even you can see all these things around you. That what is the result of engineering physics? Okay. Then this was if the physics laws which were used for, like, it's actually this destruction. If I talk about, it's not a good thing, I mean, it's a destruction, but if I mean, it can be used to protect a particular nation, that it's everyone is having, but even the destructive materials can be used for the protection of the mankind. We all know these things. Okay. And last, we have focused our focus on where, I mean, we have focused our attention on which direction that physics laws must be used in optimistic manner. Okay. So now we'll discuss about our topic. Since we have seen the physical laws, okay, since we got to know somewhat about this basic physics, we get to know what we have seen somewhat about the basic physics in the previous slides. Okay. Okay, we have seen the physical world. We have seen that what we'll be studying in our future in this sessions. I mean, the upcoming physics sessions. We've seen about the physical world. So now what we'll be going through? We'll be going through our chapter, actually, the unit and measurements now. That's fine. So we'll go through now unit and measurements, which was actually a chapter as per the description. So are you ready, everyone? Yes, here we go. So at first, these are the contents. Okay, these are our objectives. First, we'll understand. See, students, now be very much focused. Keep your focus 100% here. Be concentrate. Concentration. You must maintain your concentration throughout this session now. Okay, because I will just end the session after I'll end in such a manner that this chapter will be completed. Okay. So physical quantities and units, first we'll go through this. Then we'll go through measurements, how we measure in physics. Then we go through that. Of course, if there will be measurements, there will be what? Errors. Then we go through significant figures and dimension analysis. This is the main part, students. I'll rate it 5-star. This is actually the main part. Okay. Let us go through physical quantities and units. Learning objectives, students. In this also, first we'll go through, this is a subtopic, subcontents, okay? We'll go through introduction to physical quantities, units, and system of units. So introduction, let us have introduction to physical quantities. So as per your high school physics students, okay, the number of physical quantities which you must have an introduction with are those quantities which can be measured, okay? Fine. So you must now think, is mass a physical quantity? You must keep this concept in your mind. This is a concept. This is a concept to check whether the quantity is physical or not. That if it can be measured, that is physical quantity. Now I'm asking from you, is the mass physical quantity? Yes. Of course, it's sure the mass can be measured. One material is having somewhat mass, other material, I'm not talking about weight. We'll understand what is weight. Okay, it's m mass times g, acceleration due to gravity. But now I'm not talking about that. But I am talking about this, is mass physical quantity or not? My answer is yes. Let us check it out. Yes, I'm right. Okay, victory. So mass is a physical quantity. We can measure mass by balance and weighing machines. This we all know. Next word. Yes, this is the picture so that we can get a more feel of this. Is fever a physical quantity? Fever means when you're not feeling well, you are on the bed, you are lying, you don't want to do anything. Such a kind of condition. Your health is not fine. So you will say what? Is fever a physical quantity? I think no. Okay, it's right. Yes, no. Doctor did not measure fever. He measures temperature. Temperature is a physical quantity which is measured by thermometer. So actually, whenever you are having a fever, what we do? We take a thermometer and we put the thermometer in our mouth. Okay, and the red colored mercury. Okay, or somewhat, I don't know. You can take and you might have seen any color. Okay, but what's going to happen actually in the thermometer? The mercury level will rise. The mercury level will rise. It rises. I mean, why it rises? Actually, it happens due to the heat passing in this. Okay, heat exchanges, and the result, and that can be seen by what factor? Temperature. So as the temperature increases, mercury reading also increases. Okay, so that thing can be measured, but the fever can't be measured directly. It doesn't make sense. Okay, it's a nonsense. I mean, it doesn't make sense. Fine, it's imaginative kind of thing. This is a thermometer. Fine. Now, physical quantities for you, according as per your high school syllabus, physical quantities are of two types: fundamental quantity and derived quantity. Fundamental quantity and derived quantity. First, we'll see. We'll see one by one. Okay. So fundamental quantity consists of these things. Remember, mass, length, and time. You know what the mass? It's the amount of material in the body. Length, you know. Length, it's simple. Take a scale and length. Find the length. Time, you know, time is always moving. Clock is doing tick, 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 tick. Okay. Derived quantities. Derived quantities are this: velocity, force, and work. These are what? The derived quantities. Velocity, the simple formula which you studied in the lower class is the distance upon time. Okay. Let us have more introduction to measurements. Measuring a physical quantity. Remember, we know the physical quantity which can be measured, but how to measure it? See, sometimes this is what a common person, which is not a physicist. You can say he is a physicist, but it's just about, in the household, we measure the things like this. If you want to measure something, we pull our, we stretch our hand like this and we measure the length. We try to do this. Many times, I hope you people also have gone through this thing. Foot span, we can also measure the distance via the foot. So if you see this, that if you check your maths or physics or chemistry, whatever book, if you check its length by your hand, stretch your hand. So I hope that it is just under your two hand spans. Okay, isn't it? So let us compare it also. Okay. So what is happening actually? These are all dumbbells. I'm keeping these dumbbells aligned in the direction of this ladder to measure what? To measure the length of this dumbbell. To measure the length of this ladder. Okay. So I can say, if I arrange this dumbbell, say 1, 2, 3, 4, 5, 6, 7, 8. When all these dumbbells are being arranged in a proper manner, I mean edge to edge, when where their edges are linked, I get this thing. So I can measure the length of this ladder via these dumbbells. If I want to explain somebody, I will say like this: the ladder is about 8 dumbbells long. So I took a measuring factor via which I was able to measure the length of this ladder. Okay. So comparison is also important. But what about the units? We have seen, I mean, today we are having very sophisticated measuring instruments, which can give you particular units plus the numbers. And these are all live photos in front of you. So we can compare a particular thing with a reference standard. Okay. These are all self-explanatory. Okay. I think it's not required to explain about this. Representing a physical quantity. Length is equals to 28. What does it mean? It doesn't make sense actually. But if I say 28 meter, this gives me the complete information about whatever the object the person is talking about. Is it fine? Numbers, figures will not give you anything, no information. But this, so you can say 28 units, but still it is incomplete. I can't, I can't say properly that how much it will be. But if you give me 28 meters or centimeters, then I'll think about that. Or millimeters, or kilometers, or foots, or steps. This also I can, if you give me the steps, I'll say what kind of step. First of all, I'll measure with the person's step. Is my step fine? It's having the perfect dimensions. Then I will take 28 steps. I will say this is the length of the object which you are talking about. See this. Now calculate this with this thing, that these are the dumbbells. Okay. We require how much? We require 8 dumbbells. If we align these 8 dumbbells edge to edge, okay, we'll get what? We'll get the length of this ladder. So physical quantities here, magnitude into unit. Magnitude is what? Magnitude is the magnitude of the dumbbell. Unit, I don't. Okay, unit here, unit is what? Unit here is dumbbells actually. Here the unit is W, magnitude is what? Here the unit is U. Magnitude is what? And here, so I will say 8 dumbbells. Similarly, you will see that we'll write now like this, suppose 10 meters or 10 millimeters. Okay. So these are the very basic examples. This is the magnitude and this is the unit. Magnitude, unit. This is the magnitude. This is the unit. See, now the magnitude of physical quantity, any of the objects, okay, is N1 in U1 unit and N2 in unit, U2 unit. It means like this. I can say you like this, how to explain. If I want to explain you, let us take an example, okay? Suppose something is in kilometers. Okay, say 1 kilometer is equals to how much? I will say it is equals to 1000 meters. That's fine. So if I differentiate or segregate the things here for more proper understanding, I will say 1 is the N1, kilometer is the U1, which is equals to 1000 is the N2, and meter is what? U2. So we can say N1 U1 equals to N2 U2, which is the clear. I hope you got the clear understanding of this thing. Okay, I hope you got the clear understanding. Now next is this. Let us go through an example, because numericals, if in physics there are no numericals, no applications, so it doesn't make sense. Okay. So suppose if someone asking from you, find the magnitude of the physical quantity length in foot. First of all, you must understand what is this foot is. This will be your measuring unit. This will be your measuring unit. Okay. So let us see length. Suppose 1 foot, it is actually 3 equals to 20. It's given. These are the given informations. 1 foot is actually equals to 3.28 meter. You know about the meter. Okay. So 1 foot you got. These are the conversion units. Remember what? These are what? Conversion units. So 1 foot is equals to 3.28 meter. Then the given length is this much. So they're asking you find in foot. So simple it is. I am having a particular length in 28 meters. Just divide this, as we have divided the leather into what? Dumbbells. I needed 8 dumbbells. I needed 8 dumbbells to what? Construct a ladder. Similarly, I need number of foots to complete this 28 meters. So I will adjust 1 foot, 2 foot, 3 foot, 4 foot, 5 foot. So it's simple. If I divide this 28 by 3.28, I will get the number of foots. Foots is the units, and this is a measuring value number. Okay. So let us see what the answer is. So simply divide it. Okay. So you can see here what is done. Anybody can explain this thing? See, students, here there is one mistake here. Okay. See, 1 foot is given here equals to how much? 3.28 meters. It means 1 foot is equals to multiples of the meter. Okay. 28 meter. So I can say 3.2 meter is equals to 1 foot. So I will say 1 meter is equals to 1 by 3.28 foot. So just use the unitary method here. Okay. So what you need to do? You must use here unitary method. Okay. In the lower classes, you have seen this thing, unitary method. So 1 foot equals to this much. So 1 meter will be equals to 1 upon this much foot. So 28 meters will be equals to how much? 3.28 into 28. Okay. So this will give you a number of foots here. That's fine. So this is actually wrong. We will not consider this. Remember it. Okay. So take this answer as wrong. You use this approach. If anybody is still having the doubt, please pass your comments in the comment box. Your comments are really, really important for us. Okay. Introduction to units. Now we'll have introduction to some spatial base units. So see, units are basically of two types: fundamental base units, that is, for example, meter and kilograms, and the next is derived units. So we must remember these always. These are the base units, fundamental base units. You must always remember these units. Using these units, you will be able to derive what? The derived units. Derived units example is what? It is Newton or velocity meter per second, etc. Okay. So see, system of unit consists of the complete set of units. Remember this always. That system of unit consists of what? Complete set of units. That is MKS and CGS and FPS. What are these? MKS stands for, anybody can answer? MKS means what? MKS stands for what? Meter, kilogram, second. Okay. CGS stands for what? Centigrade system. FPS for what? Foot, pound, and all. Okay. So you can see the full forms: meter, kilogram, second, centimeter, gram, second, foot, pound, and second. So these are different base units. Suppose you are given a particular length. Let me show you here. Suppose students, we are given a particular length. Suppose some stick you are given or rod is given of length L, and they ask you find its length in MKS, base, CGS, and FPS units. So for MKS, it will be somewhat in meters with the numerical value, say 3. CGS, it will be somewhat different, say equals to, say 1 meter is how much? 100 centimeters. 1 meter is equals to how much? 100 centimeters. So we say what? This will be 300 centimeters. Is this right or wrong? It's right. Okay. FPS will be somewhat in foot, which you've already seen. Foot is equals to 3.28 meters. And as we have to convert that. Okay, tell me, will it be more or less? Of course, foot is dominating. So we'll say if 3 meters approximately equals to 1 foot. So it will be approximately something 1 point something foot in this. So the same road, which is L, is equals to 3 meter in the MKS, is 300 centimeters in the CGS, is 1 point something foot in FPS. So this is the beauty of this system of units. SI system. Let us talk about the SM system, which is a very unique and basically universally followed system. This you will find everywhere in your this high class physics also. I mean high school physics also when you will study the higher level advanced physics. So you'll find everywhere the numericals applications, even in the theories. The units mostly are used as what? Is from the SI system of units. This is universally accepted units. So see, it's international system of units. SI unit is what? It is the international system of unit. Remember it. What is it? It is the international system of unit. Okay. So we'll complete it soon. See, this is SI system. See, SI system consists of 7 fundamental base unit and 2 supplementary units. So total we can say 7 plus 2 is how much? 9. Okay. 7 plus 2 is how much? It is 9 here. So these are all the things. Students, you have to remember this. There is no any other way. Remember it. Quantity for the length. See, this is the chart which you must keep in mind always. Okay, now because when you will progress towards the next physics sessions. So if you're not able to remember this, it will create a lot of problem for you to understand the advanced level physics. Okay. because this is just a core, the platform of the physics, okay, and from where everything starts. Name of the unit is meter, symbol is small m. Mass, it's what? It's the amount of material contained in the body. kg is the unit. Short form is this. I mean, symbol is this. Time, second, S. Electric current, it's ampere, A. We'll study in the future physics sessions this chapter. I mean, the topic which is electric current. We'll understand all about this in a separate chapter. Temperature we'll study in thermodynamics, KTG. Amount of substance, moles. Luminous intensity is candela. So these are complete. If I say 1, 2, 3, these are the serial numbers I'm writing here, 6, 7. These are 7 fundamental base units. So where are 2 supplementary units? So these are the 2 supplementary units. That is plane angle and solid angle. So plane angle, solid angle, you know the plane angle. Solid angle will be somewhat different. It's 3D. If it's 2D, this is 3D. Remember it. Symbols are radian and SR. Okay. So remember this 7, remember this always 7 plus 2, that is the 9 units in SI system. Plane angle is what? See this. Plane angle is defined as theta equals to S upon R. Theta is this, S is the arc length. If suppose I take 2 points and open an angle like this. Suppose A and B are the 2 points on this circle. And if I open an angle, this S is the arc, R is the radius of the circle. Okay. This is the center of the circle. So I will say theta is equals to arc upon radius or radii. Okay. And if I talk about the solid angle, this omega, this is, see students, this has been pronounced as omega. This omega is what? It's a solid angle. It's given like this. Area, this is the area of the top funnel. Let me mark it with this. Okay, let me highlight this with the yellow color. This is the area of the base upon R is the radius of the sphere, you can call like this. R is the radius of the sphere. SR are basically what? It's a unit. Steradian, okay. Here it is radian, you can see the units now, radian and steradian. So it's a radian, this is steradian. These are what? The numerical values. We'll put down numbers and you'll get a numerical value. This is the unit. We have the numerical magnitude plus, multiplied by unit. This gives us the perfect formula, okay. Here also we are having the unit and the magnitude. This gives us perfect formula. I think all the things are clear. So students, there is, here you can see it's a very fine picture. Suppose if I switch on this torch, the light will come out. Everyone knows this thing. If I switch on this torch, light will come out. Suppose I want to measure this. Suppose it's a laser light. It's a laser beam. Suppose the torch is a source of laser beam. And this laser beam you're able to see on your screen. This is a laser beam, the violet color arrow. If I want to measure this, I take a scale and I got this thing. And students, I can also find the speed. So somehow the speed comes like this. C, okay, you can see this. It's this much. I mean, light takes something, say 2.99 10 raised to power 8 meters. It takes this much meters in 1 second. So this is a speed, you know this. And we know approximately, as per the theory points, we know this thing. The speed of the light is 3 into 10 raised to power 8 meter per second. So these are some kind of these things. Because laser beam also is kind of electromagnetic wave. Now, if we talk about the measurement of the length, sorry, okay. Now we talk about the measurement of the lengths. There are different methods. First is the direct method. Second is indirect. Direct, if you talk about by meter scale, simple, no, it's a common sense. Direct matlab kya? Take the resources, use the resource and find the length. Vernier calipers is something maybe you know, maybe you don't know, I don't know, okay. By screw gauge. Indirect is what? Indirect is, suppose if you want to measure the distance of the moon from the earth, there are indirect methods which have been implemented. No need to worry about this. This is just for your information, okay? See, measurement by larger distances given by the parallax method. What do you mean by larger distances? I mean the distances of the moon from the earth, sun from the earth, okay, like the heavenly bodies. So let us take a very simple example of parallax method. Suppose you are having a tall building. If the topmost point is marked with the A point, okay, fine. So if you want to see the distance, students, I will mark the theta angle here. So from my point, I'll compare this height. Say it's h by 2. Complete height is h. Here the theta will be same. So always remember the edge point will make angle theta with the base of this tree, also the base of this small tower. Or suppose we are standing here. Okay. So you have to compare the tan of the theta. This is the mathematics which I'm providing you here. H by 2 base distance. Compare that again. H by 2 base distance x2, x1. Put the values, get the answer. See this. Parallax method take the advantage of this theta angle to be same. Okay, it's very easy. Suppose we need to estimate the diameter of the star by parallax method. So I can say like this. Let us mark the 2 points on the ends of this star like this. Now suppose alpha is the angle which is made by these 2 points at the O point here, which is D distance from this A and B point. D means what? Capital D I'm talking about. How much distance? Capital D. Alpha will come out to be small d upon capital D. This will be this. Why I'm writing this? Because it's theta equals to arc upon radii. Think like this, where the arc is not curved here, it's straight. Treat alpha to be very small. So through this we'll get what? Simple diameter. Diameter is what? It will be d equals to capital D alpha. So these are some methods, students, through which we find the bigger diameters. Okay. If we also we need to find for the micro scale particles. If you want to find the measurements, distances, whatever at the micro scale, macro is big, micro is small, very small. For this also some methods are implemented. Suppose you're having oleic acid, solution of alcohol. You know what happens? So these are the conversion units in each of them. Suppose you need to find size of the molecule. So somehow what do you do? These are different methods given. Okay. Suppose volume of the end drop of solution is this. So actually these are all the same things, students. Nothing changed in this. I mean, so the main extract if I take, the ultimate extract if I take, that there are many methods, okay, direct and indirect, so which you can find, you can measure the distances of the micro things also. I mean the sizes, the dimensions of the micro things also, and sizes of the macro things also. Okay. Now let us see the measurement of mass and time, which is more important. If I talk about the measurement of mass, we know we are having this common method to measure the things. That is, keep the potato. If suppose you go to the marketplace, okay, if you want to buy something, this is actually, this kind of balance is still, it has been taken under use, but more you will find in the older times. Today, everything is electronic. We know this thing. We're having the electronic balance. We're having everything electronic. So what they used to do is this: if you buy say a kg of a pound of the potatoes, and they will take a stone which is fixed with the mark of say 2 kg something, and they will measure, and they will put it. If the balance is in the same level, okay, then it's fine. Otherwise, they will put more stones. Up to what condition? The condition is this: this must be straight line, the top level. Okay. So for the larger planets, if you want to find the mass, how we can find? There is some gravitational method. This we will discuss in the upcoming physics sessions on this channel. Okay. So this is a chart which this you don't have to remember. Don't worry, students. This thing you don't have to remember. There are different objects, say electron, proton, uranium, and all these things. Uske the ranges of masses are given in kg. Okay, for your information. So see, Boeing 747 aircraft, boom, it's 10⁸ kg in mass. So you can think how much it is. See, we people are approximately having the mass of 60-70 kg maybe. Right? This is 100040 again 40. Can't you imagine? Can you imagine, students? This much kg. A human can't have. So it's a Boeing 747 aircraft. How to measure the time? We have seen to measure the mass, length, but how to measure the time? See, we know everyone is having the clock, but is the clock same everywhere? I mean, in the US, UK, or Ukraine, the war is going on, or Russia, or like India, is the watch same? Yes. So universally, one kind of standard system for measuring the time has been found out, which is given by the cesium clock, which says 1 second is equals to time needed for 91926317770 vibrations of the radiation corresponding to transit between the two hyperfine levels of ground state of cesium-133 atom. So from the beginning, this time has been accepted. Okay. Remember, students, from the beginning, this time has been accepted. Okay, ready for the challenge? So we are having few things left. The challenge is this. So they say moon is observed from the two diametrical opposite points, say A and say B. The angle theta subtended at the moon by the two direction observation is 1 degree like this. You have to find the distance of the moon from the earth. I mean, this D, you have to find it out. So parallax angle says this 1 degree 54 minutes is approximately equals to this much. Theta will give you this much minutes. Okay. So 1 degree will be approximately equals to this much radian. This conversions you must remember. Okay, fine. Because we know, students, pi radian is equals to 180 degree. So 1 degree will be equals to pi upon 180 radians. Okay. So if I convert minutes into radians, 1 degree equals to 60 minutes. So convert into radian, you'll get the answer. So ultimately, I will get this much radian. So this theta equals to actually 3.32 10 to the power minus 2 radians. Fine. B value I'm having what? Diameter is given what? This much, 1.2. So simple, you have to put the value. That is what? B. Theta is equals to arc upon radius kind of. Theta is equals to this value, 3.3 to 10 minus 2 radian. B, you are given 1.276 10 to the power 7 meter. D, you can find it out easily. So the answer is, you'll get the answer equals to this. This is what? Arc. It behaves like, it looks like arc, which is not tilted. Okay. D is the basically distance of the moon from the planet. Okay. Earth. This is the radii. Consider like this. Suppose it's a big, I'm not talking about the earth. Earth is not having such a kind of radii, but just for imagination. Okay. So, oh no, it will be more big. Let me show you. So it will be, I will say, this is a center. So that kind of circle or the sphere will be very, very big, such that this D will be what? Radii everywhere. Okay. So your answer comes out to be this much. So this is the distance of the moon from the earth. Okay. That's fine. Good. So let us talk about errors in measurement. What are the errors in measurement, students? So basically, there are different errors. This we'll talk about in the next class. Okay. We'll talk about accuracy and precision. That's fine. Let me see. Just hold on, students. Just have a wait. Okay. Okay, students. So from the next class, hold on. In the next class, we'll talk about errors in measurement. Okay. Till then, bye bye, everyone. And what are the notes will be provided to you in the description link. Okay, fine. Till then, bye bye, and we'll meet in the next class. If you are having any demands, sir, please start this chapter. Suppose you want me to start directly from kinematics. So comment me in the comment box. Okay, put a comment in the comment box. And if you want to join the WhatsApp group, please, this is the number. There are many students waiting for you. Okay, and like you to join this journey of the physics session. Okay. And here, whatever the topic you want to study, what you want to understand, you can put in the comment box. Also on this number, you can text. That's fine. So bye bye, everyone. We'll meet in the next class. Till then, be happy, study well, and enjoy your physics. Okay. So bye bye. I'm ending the session here.